Chapter 11 of A Popular History of Astronomy During the 19th Century. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Aaron Carlo, San Clemente, California. A Popular History of Astronomy During the 19th Century by Agnes Mary Clerke. Recent Comets Continued, Part 2. At Ann Arbor Observatory, Michigan, on July 14th, a comet was discovered by Dr. Skibbereen, which, as his claim to priority is undisputed, is often allowed to bear his name, although designated in strict scientific parlance Comet 1881 IV. It was observed in Europe after 3 days, became just discernible by the naked eye at the end of July, and brightened consistently up to its perihelion passage, August 22nd, when it was still about 50 million miles from the sun. During many days of that month, the uncommon spectacle was presented of two bright comets circling together, though at widely different distances, round the north pole of the heavens. The newcomer, however, never approached the pristine lustre of its predecessor. Its nucleus, when brightest, was comparable to the star Cor Caroli, a narrow, perfectly straight ray proceeding from it to a distance of 10 degrees. This was easily shown by Brédikhine to belong to the hydrogen type of tails, while a strange faint second tail or bifurcation of the first one, observed by Captain Noble, August 24th, fell into the hydrocarbon class of emanations. It was seen August 22nd and 24th by Dr. F. Turby of Louvain as a short nebulous brush, like the abortive beginning of a congeries of curving trains, but appeared no more. Its well-attested presence was significant of the complex constitution of such bodies and the manifold kinds of action progressing in them. The only peculiarity in the spectrum of Skibbereen's comet consisted in the almost total absence of continuous light. The carbon bands were nearly isolated and very bright. Barely from the nucleus proceeded a rainbow-tinted streak, indicative of solid or liquid matter, which, in this comet, must have been of very scanty amount. Its visit to the sun in 1881 was, so far as is known, the first. The elements of its orbit showed no resemblance to those of any previous comet, nor any marked signs of periodicity, so that, although it may be considered probable, we do not know that it is moving in a closed curve, or will ever again penetrate the precincts of the solar system. It was last seen from the southern hemisphere October 19th, 1881. The third of a quartet of lucid comets visible within 16 months was discovered by Mr. C. S. Wells at the Dudley Observatory, Albany, March 17, 1882. 2 days later, it was described by Mr. Louis Boss as a great comet in miniature, so well defined and regularly developed were its various parts and appendages. Discernible with optical aid early in May, it was on June 5th observed on the meridian at Albany just before noon, an astronomical event of extreme rarity. Comet Wells, however, never became an object so conspicuous as to attract general attention, owing to its immersion in the evening twilight of our northern June. But the study of its spectrum revealed new facts of the utmost interest. All the comets till then examined had been found, with the two transiently observed exceptions already mentioned, to conform to one invariable type of luminous emission. Individual distinctions there had been, but no specific differences. Now all these bodies had kept at a respectful distance from the sun, for of the great comet of 1880 no spectroscopic inquiries had been made. Comet Wells, on the other hand, approached its surface within little more than 5 million miles on June 10th, 1882, and the vicinity had the effect of developing a novel feature in its incandescence. During the first half of April, its spectrum was of the normal type, though the carbon bands were unusually weak, but with approach to the sun they died out, and the entire light seemed to become concentrated into a narrow, unbroken, brilliant streak, hardly to be distinguished from the spectrum of a star. This unusual behaviour excited attention, and a strict watch was kept. It was rewarded at the Dunecht Observatory, May 27, by the discernment of what had never before been seen in a comet, the yellow ray of sodium. By June 1st, this had kindled into a blaze overpowering all other emissions. The light of the comet was practically monochromatic, and the image of the entire head, with the root of the tail, could be observed like a solar prominence, depicted in its new saffron vesture of vivid illumination within the jaws of an open slit. At Potsdam, the bright yellow line was perceived with astonishment by Vogel on May 31st, and was next evening identified with Fraunhofer's D. Its character led him to infer a very considerable density in the glowing vapour emitting it. Hasselberg founded an additional argument in favour of the electrical origin of cometary light on the changes in the spectrum of comet Wells, for they were closely paralleled by some earlier experiments of Wiedemann, in which the gaseous spectra of vacuum tubes were at once effaced on the introduction of metallic vapours. It seemed as if the metal had no sooner been rendered volatile by heat than it usurped the entire office of carrying the discharge, the resulting light being thus exclusively of its production. Had simple incandescence by heat been in question, the effect would have been different. The two spectra would have been superposed without prejudice to either. Similarly, the replacement of the hydrocarbons bands in the spectrum of the comet by the sodium line proved electricity to be the exciting agent. For the increasing thermal power of the sun might, indeed, have ignited the sodium, but it could not have extinguished the hydrocarbons. Sir William Huggins succeeded in photographing the spectrum of Comet Wells by an exposure of 1 hour and a quarter. The result was to confirm the novelty of its character. None of the ultraviolet carbon groups were apparent, but certain bright rays, as yet unidentified, had imprinted themselves. Otherwise, the spectrum was strongly continuous, uninterrupted even by the Fraunhofer lines detected in the spectrum of Tebbutt's comet. Hence, it was concluded that a smaller proportion of reflected light was mingled with the native emissions of the later arrival. All that is certainly known about the extent of the orbit traversed by the first comet of 1882 is that it came from, and is now retreating towards, vastly remote depths of space. An American computer found a period indicated for it of no less than 400,000 years. A. Thraen of Dingelstedt arrived at one of 3,617. Both are perhaps equally insecure. We have now to give some brief account of one of the most remarkable cometary apparitions on record, and, with the single exception of that identified with the name of Halley, the most instructive to astronomers. The lessons learned from it were as varied and significant as its aspect was splendid, although, from the circumstance of its being visible in general only before sunrise, the spectators of its splendour were comparatively few. The discovery of a great comet at Rio Janeiro, September 11, 1882, became known in Europe through a telegram from M. Cruls, director of the observatory at that place. It had, however, as appeared subsequently, been already seen on the 8th by Mr. Finlay of the Cape Observatory, and at Auckland as early as September 3rd. A later but very singularly conditioned detection, quite unconnected with any of the preceding, was effected by Dr. Common at Ealing. Since the eclipse of May 17th, when a comet, named Tewfik in honour of the Khedive of Egypt, was caught on Dr. Schuster's photographs, entangled, one might almost say, in the outer rays of the corona, he had scrutinized the neighbourhood of the sun on the infinitesimal chance of intercepting another such body on its rapid journey thence or thither. We record with wonder that after an interval of exactly 4 months, that infinitesimal chance turned up in his favour. On the forenoon of Sunday, September 17th, he saw a great comet close to and rapidly approaching the sun. It was, in fact, then within a few hours of perihelion. Some measures of position were promptly taken, but a cloud veil covered the interesting spectacle before midday was long past. Mr. Finlay at the Cape was more completely fortunate. Divided from his fellow observer by half the world, he unconsciously finished, under a clearer sky, his interrupted observation. The comet, of which the silvery radiance contrasted strikingly with the reddish-yellow glare of the sun's margin it drew near to, was followed continuously right into the boiling of the limb, a circumstance without precedent in cometary history. Dr. Elkin, who watched the progress of the event with another instrument, thought the intrinsic brilliancy of the nucleus scarcely surpassed by that of the sun's surface. Nevertheless, it had no sooner touched it than it vanished as if annihilated. So sudden was the disappearance at 4 hours 40 minutes 58 seconds Cape Mean Time that the comet was at first believed to have passed behind the sun. But this proved not to have been the case. The observers at the Cape had witnessed a genuine transit, nor could non-visibility be explained by equality of lustre, for the gradations of light on the sun's disk are amply sufficient to bring out against the dusky background of the limb any object matching the brilliancy of the centre, while an object just equally luminous with the limb must inevitably show dark at the centre. The only admissible view, then, is that the bulk of the comet was of too filmy a texture, and its presumably solid nucleus too small, to intercept any noticeable part of the solar rays, a piece of information worth remembering. On the following morning, the object of this unique observation showed, in Sir David Gill's words, an astonishing brilliancy as it rose behind the mountains on the east of Table Bay, and seemed in no way diminished in brightness when the sun rose a few minutes afterward. It was only necessary to shade the eye from direct sunlight with the hand at arm's length to see the comet, with its brilliant white nucleus and dense white, sharply bordered tail of quite half a degree in length. All over the world, wherever the sky was clear during that day, September 18th, it was obvious to ordinary vision. Since 1843, nothing had been seen like it. From Spain, Italy, Algeria, southern France, dispatches came in announcing the extraordinary appearance. At Cordoba, in South America, the blazing star near the sun was the one topic of discourse. Moreover, and this is altogether extraordinary, the records of its daylight visibility to the naked eye extend over 3 days. At Rias, near Tarragona, it showed bright enough to be seen through a passing cloud when only 3 of the sun's diameters from his limb, just before its final rush past perihelion on September 17th, while at Cartagena in Spain on September 19th, it was kept in view during 2 hours before and 2 hours after noon, and was similarly visible in Algeria on the same day. But still more surprising than the appearance of the body itself were the nature and relations of the path it moved in. The first rough elements computed for it by Mr. Tebbutt, Dr. Chandler, and Mr. White, assistant at the Melbourne Observatory, showed at once a striking resemblance to those of the twin comets of 1843 and 1880. This suggestive fact became known in this country, September 27th, through the medium of a Dunecht circular. It was fully confirmed by subsequent inquiries, for which ample opportunities were luckily provided. The likeness was not, indeed, so absolutely perfect as in the previous case. It included some slight, though real, differences, but it bore a strong and unmistakable stamp, broadly challenging explanation. 2 hypotheses only were really available. Either the comet of 1882 was an accelerated return of those of 1843 and 1880, or it was a fragment of an original mass to which they also had belonged. For the purposes of the first view, the resisting medium was brought into full play. The opinion of its efficacy was for some time both prevalent and popular, and formed the basis, moreover, of something of a sensational panic. For a comet which, at a single passage through the sun's atmosphere, encountered sufficient resistance to shorten its period from 37 to 2 years and 8 months, must, in the immediate future, be brought to rest on his surface, and the solar conflagration thence ensuing was represented in some quarters, with more license of imagination than countenance from science, as likely to be of catastrophic import to the inhabitants of our little planet. But there was a test available in 1882 which it had not been possible to apply either in 1843 or in 1880. The two bodies visible in those years had been observed only after they had already passed perihelion. The third member of the group, on the other hand, was accurately followed for a week before that event, as well as during many months after it. Finlay's and Elkin's observation of its disappearance at the sun's edge formed, besides, a peculiarly delicate test of its motion. The opportunity was thus afforded, by directly comparing the comet's velocity before and after its critical plunge through the solar surroundings, of ascertaining with approximate certainty whether any considerable retardation had been experienced in the course of that plunge. The answer distinctly given was that there had not. The computed and observed places on both sides of the sun fitted harmoniously together. The effect, if any were produced, was too small to be perceptible. This result is, in itself, a memorable one. It seems to give the coup de grace to Encke's theory, discredited in addition by Böcklund's investigation, of a resisting medium growing rapidly denser inwards. For the perihelion distance of the comet of 1882, though somewhat greater than that of its predecessors, was nevertheless extremely small. It passed at less than 300,000 miles of the sun's surface, but the ethereal substance long supposed to obstruct the movement of Encke's comet would there be nearly 2,000 times denser than at the perihelion of the smaller body, and must have exerted a conspicuous retarding influence. That none such could be detected seems to argue that no such medium exists. Further evidence of a decisive kind was not wanting on the question of identity. The Great September Comet of 1882 was in no hurry to withdraw itself from curious terrestrial scrutiny. It was discerned with the naked eye at Cordoba as late as March 7, 1883, and still showed in the field of the great equatorial on June 1st as an excessively faint whiteness. It was then about 480 millions of miles from the earth, a distance to which no other comet, not even excepting the peculiar one of 1729, had been pursued. Moreover, an arc of 340 out of the entire 360 degrees of its circuit had been described under the eyes of astronomers, so that its course came to be very well known. That its movement is in a very eccentric ellipse, traversed in several hundred years, was ascertained. The later inquiries of Dr. Kreutz, completed in a volume published in 1901, demonstrated the period to be of about 800 years, while that of its predecessor, in 1843, might possibly agree with it, but is much more probably estimated at 512 years. The hypothesis that they, or any of the comets associated with them, were returns of an individual body is peremptorily excluded. They may all, however, have been separated from one original mass by the divellent action of the sun at close quarters. Each has doubtless its own period, since each has most likely suffered retardations or accelerations special to itself, which, though trifling in amount, would avail materially to alter the length of the major axis, while leaving the remaining elements of the common orbit virtually unchanged. End of Recent Comets Continued, Part 2. Recording by Aaron Carlo, San Clemente, California.